Hello everyone, welcome back to another show. This time I'll be doing application of derivatives April shift of 2024 JEE main. We'll discuss the questions one by one. Also we'll see the number of questions appeared from different topics of this chapter. We got rate measure, increasing and decreasing function, maxima, minima, but no questions were asked from rate measure. Increasing and decreasing function, 3 questions were asked. On critical points, 2 questions. Maxima, minima, local maxima, local minima, 9 questions, and miscellaneous 1 question. Altogether, we have 15 questions of this chapter from 2024 April shift, JEE main. Okay, so we'll discuss the questions one by one along with solving the problems. We'll discuss the concepts too, so that it is beneficial for you to watch this video. Okay, the given function f of x equal to 3 into root of x minus 2 plus root of 4 minus x be a real valued function. Alpha and beta are respectively the minimum and maximum values of f. Want to find alpha square plus 2 beta square equal to how much? So what we'll do is we'll find the domain of the function f, because there is square root here. No, whenever there is square root, no, square root of x is defined such that x is greater than or equal to 0. So terms inside the root should be positive or 0. So that concept will apply and find out the domain of the function f. We can't give any value of x here because there is square root function, right? So first we'll find the domain of this function. Find domain of this and find domain of this. Then find the intersection of those two, because I need to find the values of x so that both the terms are well defined at the same time. For same values of x, this as well as this, both should be well defined, correct? So then only it's possible to find the derivative in the domain of the function. So what we'll do is I'll find the domain of this function f and use the concept of absolute maxima and absolute minima. Finding the maximum and minimum values of the function in the closed interval. We know the procedure, right? We want to find the critical point first, and also we're finding the function value at the critical points and the function value at the end points and compare those, correct? If say A is a critical point, find out f of A, and B and C are the endpoints of the interval, find out the function value at the endpoints, compare the function values, greatest among them is absolute maximum and the least among them is the absolute minimum. So I'm using that concept now. So first we'll find the domain of this function. Root of x minus 2 is defined such that x minus 2 is greater than or equal to 0, right? So we'll begin with finding domain of the function f. Root of x minus 2 is defined. Root of x minus 2 is defined for x minus 2 greater than or equal to 0. That means x is greater than or equal to 2. Root of 4 minus x is defined. Root of 4 minus x is defined for 4 minus x is greater than or equal to 0. That will give x is less than or equal to 4. This is called 1. This is called 2. 1 intersection 2 gives, 1 intersection 2 gives x belongs to the interval 2 to 4, correct? Greater than or equal to 2 and less than or equal to 4. See, if you want, I can represent in the number line. 2 is here, 4 is here, correct? X greater than or equal to means right side of 2, including 2. So this is going right side, 2 to infinity. And x less than or equal to 4 is going left side. And this is the common value for both, correct? So x belongs to the interval 2 to 4. X belongs to the interval 2 to 4. That is your domain of the given function. So because I need to find the common values, because for same values of x, both the terms should be defined, correct? So then only it's possible to define the function in that interval. So 2 to 4 is the domain of this function. In that interval, we find the absolute maximum and absolute minimum value. So get the critical point of the function in this interval. I'll differentiate the given function f dash of x. F dash of x is equal to 1. Derivative of root x is 1 by 2 root x. Constant into variable. Constant keep as it is. Differentiate the variable. 3 into derivative of root is 1 by 2 root. 1 by 2 root of x minus 2 into derivative of x minus 2 is 1 plus derivative of root x is 1 by 2 root x. 1 by 2 root of 4 minus x into derivative of 4 minus x is minus 1 is equal to 0. To get the critical points, I'll equate f dash of x to 0. F dash of x equal to 0 will give the critical points, correct? So we take common denominator and simplify this. To get the critical points, we'll shift this one of the term to that side. What you get is 3 by 2 into root of x minus 2 is equal to, this is taken to that side, becomes 1 by 2 root of 4 minus x. Correct? 2 cancels. Cross multiply this. Cross multiply and rearrange the terms. So do squaring on both sides. 3 into root of 4 minus x is equal to root of x minus 2. 2 cancels. Cross multiply. Do squaring on both sides. I'll get 3 square 9 into 4 minus x is equal to x minus 2. So 9 into 4 is 36 minus 9x is equal to x minus 2. 36 plus 2, 38 is equal to 10x. X is equal to 38 by 10, which is 19 by 5. Value of x is 19 by 5, which is the critical point of this function. Critical points are the points where derivative vanishes or the points where derivative is not defined, correct? So here the endpoints of the interval, of course I can tell at x equal to 2 and x equal to 4 also I can take them as critical points. Anyway they are coinciding with the endpoints of the interval, right? 2 to 4. So 2 and 4 also the critical points here. Also they are the endpoints of the interval, correct? F dash of 2 is not defined, correct? Derivative is not defined when you put x equal to 2 here. Also f dash of 4 is not defined because denominator becomes 0 means the function is not defined. Derivative is not defined. Therefore derivative is not defined is also critical points. So I can take the critical points as 19 by 5, 2 and 4. Okay. So I am evaluating the function at the end points as well as evaluating the function at the critical points. So find out f of 2, f of 4 and f of 19 by 5. Okay. F of 2 is therefore function value. Function value is how much? F of 2. F of 2 means you need to substitute x equal to in this. Put x equal to 2 minus 2 0. 3 into 0 0, correct? 3 into root of 2 minus 2 plus root of 4 minus 2. Putting x equal to, this part is 0, I am getting root 2. F of 2 is root 2. Find out f of 4. F of 4 is 3 into root of 4 minus 2 plus root of 4 minus 4. 4 minus 4 is 0. So I am getting 3 root 2 here. 3 root 2, correct? And I need to find f of 19 by 5. F of 19 by 5 is how much? 3 into root of 19 by 5 minus 2. 19 by 5 minus 2 plus root of 4 minus 19 by 5. 4 minus 19 by 5 is how much? 19 by 5 minus 2. That will be 5 2 is 10. 19 minus 10. 19 minus 10 is 9. 9 by 5. Root of 9 by 5. Root of 9 by 5 is 3 by root 5. Plus 4 into 5, 20. 20 minus 19. 20 minus 19 is 1. Correct? 1 by 5. Root of 1 by 5 is 1 by root 5. So this becomes 3 into 3, 9 by root 5 plus 1 by root 5, 10 by root 5. 10 by root 5 is going to be equal to 2 root 5. Correct? Compare these function values, root 2, 3 root 2 and 2 root 5. So greatest among them is I can give 2 root 5 guarantee value, correct? Because root 2 is approximately 1.414. 1.414 into 3. 1.414 into 3 is 4.2 something. Whereas root 5 is really nearly equal to 2.23. 2.23 into 2 is 4.46. So this is bigger than this. So smallest is alpha. Correct? Alpha is the minimum value. This is your alpha. And this is your beta. Correct? Beta and alpha we got. This is the smallest value and this is the greatest value in the interval 2 to 4. So we need to find alpha square plus 2 times beta square. Finally, therefore, alpha square plus 2 into beta square. Alpha we got root 2. Root 2 square plus 2 into beta we got 2 root 5. Root 2 square is 2. 2 root 5 square. 2 square is 4. Root 5 square is 5. 5 into 4, 20. 20 into 2 becomes 40. 40 plus 2 is 42. So answer is 42. Option A. Question asked on 4th of April, second shift, JEE Main 2024. Move on to the next one. Hope you understand this. Finding the critical points of the function. First, you find the domain of the function and find out the critical points of that function in that interval. Evaluate the function at the critical points. Evaluate the function at the endpoints of the interval. Of course, 2 and 4 also the critical points here, because at x equal to derivative is not defined. At x equal to 4 also derivative is not defined. So critical points, 2 of the critical points are same as the endpoints of the interval. Finding the function value at the endpoints, finding the function value at the critical points, compare the function values. Greatest is absolute maximum value, least is absolute minimum value. Get alpha and beta and substitute in that expression alpha square plus 2 beta square. Move on to the next one. Question number 2. F from R to R be a thrice differentiable function such that f of 0 is 0, f of 1 is 1, f of 2 is minus 1, f of 3 is 2, f of 4 is minus 2. The minimum number of zeros of 3 f dash into f double dash plus f into f triple dash of x is how much? So you need to find the minimum number of zeros for this function. Minimum number of zeros you have to find out of this function. Okay. So the thrice differentiable function. So thrice differentiable function. So what we'll do is we'll plot the function values roughly. Roughly we'll sketch the function values here. So we'll draw the graph just for understanding purpose. How many zeros the function f will find out. Okay. F of 0 is 0, that is x-axis here. I mean the origin. Origin is there, x equal to 0, y equal to 0. F of 1 is 1, so at x equal to 1 the function value is here. X equal to the function value is minus 1 somewhere down below the x-axis. F of 3 is 2, again it is above the x-axis. F of 4 is minus 2 somewhere here like this. Okay, so this is the plotting the points like this. F of 0 is 0, F of 1 is 1, curve goes up like this. F of 2 is minus 1, again comes down like this, correct? F of 2 is minus 1. And f of 3 is 2, goes up like this, f of 3 is 2, and f of 4 is minus 2. So graph is something like this. Graph is something like this. I can tell the function f has how many zeros. Zeros means the intersection points with the x-axis. 1, 2, 3, 4, correct? 4 zeros are there for the function f. Clearly, looking at the function values, various function values are given. Clearly, f has 4 zeros. Clearly, f has 4 zeros, minimum 4 zeros. It can have more than, because some function values are not given here. Not every function value is given here, correct? Not the function value is given at every point of the domain of the function. Some function values are given. Domain is of course R here, correct? So certain values are given, correct? Certain function values are given. Looking at that, I can tell the function f has minimum 1, 2, 3, 4. 4 zeros. F has minimum 4 zeros. It can have more than that also. Minimum 4 zeros. Minimum 4 zeros. Want to find the minimum number of zeros for this expression. So this expression is derived from where we need to find it first. 3 f dash f double dash plus f into f triple dash. Suppose we start with derivative of f into f dash. We consider d by derivative of f into f dash. Consider f into f dash dash. What is derivative of f into f dash? Need to apply the product rule here. First function keep as it is, differentiate the second, plus second function keep as it is, differentiate the first. So what I am going to get here is f into f double dash plus f dash into derivative of f is f dash the whole square. Correct? Applying the product rule. Now I'll consider double derivative of this. F dash double dash. That means you're differentiating the first derivative to get the second derivative. So differentiate this. Again apply the product rule for this. How to differentiate f into f double dash? First function keep as it is. Differentiate the second function f triple dash plus f double dash into f dash into f double dash. Here differentiate as a differentiate x square. Derivative of x square is 2x. 2 into f dash into derivative of f dash is f double dash. We can add the like terms. See, these two are like terms. F dash f double dash plus 2 f dash f double dash. If you add these two, I'll get 3 f dash into f double dash plus f into f triple dash. Correct? Getting like this. which is our given expression. 3f dash into f double dash plus f into f triple dash. That is our expression. So this is nothing but the second derivative of f into f dash. If f has minimum 4 zeros, I can conclude that f dash will have minimum 3 zeros. Okay. So f dash will have 3 zeros. From f has minimum 4 zeros. By graphically we got an idea. By plotting the points we got the graph of the function. From the graph I can tell f has minimum 4 zeros. So f dash will have minimum 3 zeros. Correct? F dash has minimum 3 zeros. Therefore, f into f dash has minimum 7 zeros, because f has minimum 4 zeros from this, correct? F dash has minimum 3 zeros. The product f into f dash has minimum 7 zeros. Has minimum 7 zeros. Has minimum 7 zeros. Correct? I want to find what? My expression is this. This expression is second derivative of f into f dash. That means f into f dash will has minimum 6 zeros. Has minimum 6 zeros, because derivative will have 1 less 0, correct? And f into f dash double dash will have minimum 5 zeros. Will have minimum 5 zeros, has minimum 5 zeros. So required answer is 5. The minimum number of zeros of this expression is 5. Okay. Question asked on 4th of April, second shift, JEE Main 2024. Hope it's clear. The function f has n zeros, minimum n zeros, derivative will have n minus 1 zeros. Most of the time I can discuss it as a polynomial function too in that case. Even otherwise also it works. Okay. We'll move on to the next one. A rectangle ABCD of sides 2 and 4 are inscribed in another rectangle PQRS such that the vertices of the rectangle ABCD lie on the sides of the rectangle PQRS. A and B are the sides of the rectangle PQRS. When its area is maximum, find A plus B the whole square. So there is one rectangle and there is one more rectangle, two rectangles. One rectangle is inscribed in another rectangle. ABCD is a rectangle having sides 2 and 4. Okay, we shall draw the rough sketch. Okay, ABCD is a rectangle with sides 2 and 4, which is inscribed in another rectangle PQRS such that the vertices of the rectangle ABCD lie on the sides of the rectangle PQRS. So this is a rectangle ABCD. Rectangle ABCD I'll take. This is a rectangle ABCD. Okay, ABCD is a rectangle. ABCD is a rectangle and having sides 2 and 4. Length of these sides are 2 and 4. Okay, 2 and 4 are the length of the sides. Sorry, 2 and 4 are the length of the sides. Opposite sides are equal and parallel. This is 2, this is 4. Check. 4 and this is 2, correct? So another rectangle is there. With this rectangle is inscribed in another rectangle PQRS. So like this, such that the vertices of the rectangle ABCD lie on the sides of the rectangle PQRS. So this is my rectangle PQRS. Something like this. Vertices of ABCD are lying on the sides of PQRS. Like this. Okay. PQRS. PQRS is this rectangle I'll call. PQRS. Okay. In a rectangle, we know that each of the corner angle is equal to 90 degree, right? So this angle should be 90 degree here. This angle is 90. So let this angle be equal to theta. I'll express, we know the sides of PQRS are, rectangle PQRS has sides A and B, correct? Let PQ be equal to A. Let PQ be equal to A. and let RQ be equal to B. RQ be equal to B. Okay. PQ is A. PQ is A and RQ is B. RQ is B. PQ and RQ, opposite sides are equal and parallel. So PQ should be equal to SR and RQ is same as SP. Okay. So what we'll do is we'll find out the sides A and B in terms of the angle theta. I'll mark this angle as theta here. Okay. This angle you call it as theta here. This angle is theta. Okay. Angle CBQ is theta. I'll represent here. Angle CBQ is equal to theta. There is no space to mark there, so I won't represent there. So what we'll do is we go to triangle BCQ and find out cos theta. If you find cos theta is adjacent side by hypotenuse, correct? In triangle BCQ, or in triangle CBQ, whatever, in triangle CBQ, in triangle CBQ, cos theta is equal to how much? Cos theta is equal to adjacent side by hypotenuse, correct? Adjacent side is BQ, correct? BQ. Hypotenuse is BC. BC is 2, correct? Adjacent side by hypotenuse, BQ divided by BC. BC is 2, correct? So BQ is equal to 2 cos theta. BQ is equal to 2 cos theta, I get. Okay. And if this angle is theta, angle ABR, that becomes 90 minus theta, this angle, correct? And this is 90, corner angle is 90 degree. In angle ABR is 90 minus theta. Angle ABR is going to be equal to how much? 90 degree minus theta. Because this angle is 90, correct? Because this angle is 90, this is theta, even this is 90, so this should be 90 minus theta. So this is a linear angle, correct? This is going to be linear angle. 90 plus 90 minus theta plus theta will be 180 degree. Even this angle is 90 degree, correct? So this will be 90 minus theta, angle ABR. So if you go to triangle ABR, in triangle ABR, I can define sine of 90 minus theta as well as cos of 90 minus theta. I'll go for cos of 90 minus theta. Okay, this angle is 90 minus theta. Cos is adjacent side by hypotenuse. Opposite to 90 is hypotenuse. AB is hypotenuse. AB I know length 4. So cos of 90 minus theta is equal to cos of 90 degree minus theta is equal to what? Opposite side by adjacent side by hypotenuse. Cos of 90 minus theta is going to be BR by 4. BR divided by 4. And we know cos of 90 minus theta is sin theta by concept of allied angles. So I get BR is equal to 4 sin theta. BR is equal to how much? 4 into sin theta. BQ is 2 cos theta. BQ is 2 cos theta. BR is 4 sin theta. So 2 cos theta plus 4 sin theta. The sum of those two is going to be RQ. Correct? Therefore RQ is RQ, which is our B, correct? RQ is B, which is equal to sum of these two, BQ plus BR. BQ plus BR. BQ we got 2 cos theta, 2 cos theta plus BR is 4 sin theta. That is one of the side of the rectangle PQRS. So I'll find out CQ and CP from this. This angle is 90 degree, correct? Here this was theta, this will be 90 minus theta, this again becomes theta. In triangle CDP, you can find out, I want to find CP in terms of CD, because CD we know 4. So in triangle CDP, you can find out, in triangle CDP, I'll find out cos theta. What is cos theta is equal to adjacent side by hypotenuse. In triangle CDP, cos theta, angle C is theta there, correct? So cos theta is going to be adjacent side by hypotenuse, CP divided by 4. CP divided by 4. So CP is going to be equal to 4 cos theta. CP is going to be equal to 4 cos theta. And I got CP, no? I need to find CQ. To find out CQ, you go to triangle BCQ. In triangle BCQ, I'll find out sin theta because this angle is theta, correct? I want to find CQ in terms of the hypotenuse. So I can define sin theta there. Sin theta is equal to, angle B is theta there. Opposite to theta is CQ, correct? Opposite side divided by hypotenuse. Hypotenuse is BC, which is 2. So CQ is equal to 2 sin theta. CQ is 2 sin theta. Therefore, I can find out the side PQ now. Therefore, PQ, which is equal to A, PQ, which is equal to A, correct? That is equal to CP plus CQ. PQ is CP plus CQ. CP plus CQ. CP is how much? 4 cos theta and CQ is 2 sin theta. Correct? CP plus CQ. 4 cos theta plus 2 sin theta. Now, area of the rectangle is no, length into breadth. I want to find the maximum area of the rectangle PQRS. A and B with the size of the rectangle PQRS when its area is maximum. So, when is the area maximum we find out of the rectangle PQRS? Area of the rectangle PQRS is area of the rectangle PQRS. Area of the rectangle PQRS is A into B, length into breadth, correct? A is 4 cos theta plus 2 sin theta. I'll use symbol C for cos and S for sin, simplicity's sake. It saves our time, correct? 4C plus 2S. C means cos, S means sin. B is what? B is here. 2 cos theta plus 4 sin theta. That will be 2C plus 4S. 2C plus 4S. Multiply this. 4 into 2 becomes 8. C into C is C square. Plus 2 into 2, 4. S, C. Plus 4 into 4, 16. C, S. Plus 2 into 4, 8. S square. We know cos square plus sin square is 1. 8 is common. Cos square plus sin square. This will become 20 SC. Cos square plus sin square is 1. So this becomes 8 plus, I can write 20 times sin theta cos theta as 2 times 10 into sin theta cos theta. Or 10 you keep outside, sorry. 10 into 2 sin theta cos theta, right? So that 2 sin theta cos theta is, we know, sin 2 theta. 10 into 2 sin theta cos theta. 10 into 2 is 20. 2 sin theta cos theta is sin 2 theta. So 8 plus 10 into, this becomes sin 2 theta. S stands for sin and C stands for cos. 2 sin theta, cos theta is sin 2 theta. 10 into sin 2 theta I'm getting. So this is area of the rectangle. We can call it as capital A. Area of the rectangle is capital A. When is this maximum? When sin 2 theta is maximum. Area of the rectangle is maximum when sin 2 theta is maximum. And sin 2 theta maximum value is 1. Sin 2 theta is equal to 1 is possible for theta equal to pi by 4. Correct? Because sin pi by 2 is 1. We know. So theta should be equal to pi by 4 for area to become maximum. So area is maximum when theta is equal to pi by 4. I'll write here itself. Area of the rectangle is maximum. Area is maximum when sin 2 theta is equal to 1. Sin 2 theta equal to 1. If they ask maximum area of the rectangle PQRS, sin 2 theta is 1. 1 into 10, 18. 18 plus, 10 into 1, 10. 10 plus 18 it becomes. Area of the rectangle becomes 18 in that case. Okay, they asked to find A plus B whole square, where A and B are the sides of the rectangle PQRS when the area is maximum. So area is maximum when sin 2 theta is 1. Sin 2 theta is 1 possible for theta is equal to pi by 4. Correct? 2 into pi by 4 is pi by 2, sin pi by 2 is 1. No, when theta is pi by 4, you find out the sides A and B, then find A plus B the whole square. When theta is pi by 4, what is the value of A and B? A is here and B is here. Correct? Put theta is equal to pi by 4. 4 into cos pi by 4 plus 2 into sin pi by 4. That becomes 6 into sin pi by 4. Theta is pi by 4, you substitute. 4 cos pi by 4. Cos pi by 4 is 1 by root 2. Sin pi by 4 also 1 by root 2. 4 into 1 by root 2 plus 2 into 1 by root 2. 6 by root 2. So when theta is pi by 4, A is going to be 6 by root 2. And B is also same, correct? B is also 2 into cos pi by 4 plus 4 into sin pi by 4. 2 into cos pi by 4 is 1 by root 2. Sin pi by 4 also 1 by root 2. 2 by root 2 plus 4 by root 2 becomes 6 by root 2. 6 by root 2 is 3 root 2. Correct? 3 root 2. This is also 3 root 2. Want to find A plus B the whole square because I can add 6 as 3 into 2. 3 into root 2 into root 2. 1 root 2 cancels. 3 root 2. A and B are 3 root 2. So A plus B whole square they asked to find. A is 3 root 2. B is 3 root 2. 3 root 2 plus 3 root 2. 6 root 2. 6 root 2 the whole square. 6 square is 36 and root 2 square is 2. 36 into 2 becomes 72. Option A. Question asked on 5th of April, first shift, JEE Main 2024. Hope it's clear. Okay, finding out the sides A and B in terms of angle theta and in terms of the sides of ABCD. Rectangle ABCD has the sides 2 and 4. Using those sides and angle theta, I'm finding out the sides PQ and QR. PQ is named as A and QR is named as B of the rectangle PQRS. Want to find the sides A and B of the rectangle PQRS such that area of the rectangle PQRS is maximum. So maximum value of PQRS is area of the rectangle PQRS is possible when sin 2 theta is 1 and maximum area of that rectangle is 18. Okay, so this is a question asked, a very nice question. Based on the drawing figure, you should get the equation for finding area of the rectangle PQRS, get an expression and maximize it and get the sides. Move on to the next one. For the function f of x equal to sin x plus 3x minus 2 by pi into x square plus x, where x belongs to interval 0 to pi by 2. They are given two statements here. F is increasing in the interval 0 to pi by 2. F dash is decreasing in the interval 0 to pi by 2. To verify statement 1, statement 2 is true or false. Okay. So first we'll differentiate this. F dash of x. Derivative of sin is cos. F dash of x is equal to. Derivative of sin x is cos x. Derivative of 3x is 3. Constant into variable. Constant keep as it is. Differentiate the variable. Derivative of x square is 2x. Derivative of x is 1. Correct? F dash of x we get. Cos x plus 3 minus constant into variable. Constant keep as it is. Derivative of x square 2x. Derivative of x 1. So in the interval 0 to pi by 2, what happens? Whether the function is increasing or not, we shall find out. Derivative should be positive for function to be increasing. For x belongs to 0 to pi by 2, what happens? For x belongs to 0 to pi by 2. For x belonging to the interval 0 to pi by 2. Cos function will lie in the interval 0 to 1. Correct? Cos x, cos 0 is 1 and cos pi by 2 is 0. Cos function will lie in the interval 0 to 1. Cos x plus 3 will lie in the interval. Cos x plus 3, this will belong to the interval 3 to 4. Correct? What about 2x plus 1 into 2 by pi? X belongs to 0 to pi by 2. 2x will belong to 0 to pi. 2x will lie in the interval 0 to pi. Correct? 2x plus 1 will lie in the interval. 2x plus 1 will lie in the interval 0 into 2 into 0, 0. Yeah, 0 plus 1, 1. This will be pi plus 1. Correct? 2x. 2x plus 1 I got. 2 by pi. 2 by pi very close. 2 by pi into 2x plus 1. So multiply by 2 by pi. 2 by pi into 2x plus 1 will lie in which interval? Will lie in the interval 2 by pi to, this will be pi plus 1 into 2 by pi. Correct? Pi plus 1 into 2 by pi. Like this. So where is cos x plus 3 minus of this? Correct? Cos x plus 3 minus of this will lie in which interval? 3 minus 2 by pi, comma 4 minus pi plus 1 by 2 by pi. So my function f dash of x will belong to the interval. I am subtracting these two correspondingly. 3 minus 2 by pi, comma 4 minus of pi plus 1 into 2 by pi. My derivative will lie in this interval. So 2 by pi is how much? 2 by 3.14. Pi is approximately 3.14. 2 by 3.14. Correct? 0.6 roughly. 3 minus 0.6. That means slightly greater than 2. This number is more than 2, I can tell, correct? More than 2. And what about this number? Pi plus 1 into 2 by pi. Pi plus 1 is 4.1, 3.14 plus 1, 4.14. 4.14 into 2 by pi. 2 by pi is 0 point something, 0.6. So this number will lie between 3 and 4. It's greater than 3. So this f dash of x, I can tell it's definitely greater than 2. Correct? Clearly, f dash of x is greater than 2. F dash of x is greater than 2. Greater than 2 means it is greater than 0 also, correct? Therefore, for all x belongs to the interval 0 to pi by 2. So function is increasing is true. F is increasing in the interval 0 to pi by 2 is true. Derivative is greater than 2 means implies derivative is greater than 0. F dash of x is definitely greater than 0 because 2 is greater than 0. For all x belongs to the interval 0 to pi by 2. Therefore, the function is increasing. F is increasing. F is increasing in the interval 0 to pi by 2. What about f dash of x? For f dash to be decreasing, f double dash should be negative. F double dash you find out. Now, f double dash of x. F double dash of x. Derivative of cos x minus sin x. Here, derivative of 3 is 0. Constant into variable. Constant keep as it is. Derivative of 2x plus 1 is 2. Correct? So, I am getting second derivative to be negative. Sin x is positive in the first quadrant, 0 to pi by 2. So, minus sin x is negative. Even this is a constant, negative. So, I can tell the f double dash of x is negative. For all x belongs to 0 to pi by 2. For all x belongs to the interval 0 to pi by 2. Second derivative is negative. Therefore, second derivative is negative means first derivative is decreasing, I can tell. Correct? F double dash of x is less than 0. Therefore, f dash of x is decreasing. F dash of x is a decreasing function. Second derivative is negative means first derivative is decreasing. So, f dash is decreasing in the interval 0 to pi by 2. Both the statements are true. Statement 1 as well as statement 2 both are true. F is increasing in the interval 0 to pi by 2 is true because derivative is positive. F dash is decreasing is true because second derivative is negative. Second derivative is negative means first derivative is decreasing function. So, both the statements are true. Both 1 and 2 are true. Option D is the answer. Question asked on 5th of April, first shift, JEE Main 2024. Want to the next one? Let the maximum and minimum values of this function where x belongs to R be capital M and small m respectively. Want to find capital M square minus small m square. So numerical type question asked. Okay. So this is a question quite different because we don't use the concept of finding derivatives here. We don't use derivative to find the maxima and minima of this function. Rather, instead of using the concept of derivative, we'll use geometrical approach. Okay. So what we'll do is we'll name this as y, root of 8x minus x square minus 12, name it as y. So let the given expression be equal to alpha. Okay, let alpha be equal to square root of 8x minus x square minus 12, root of 8x minus x square minus 12. 8x minus x square minus 12 minus 4 the whole square plus x minus 7 the whole square. What is this? Y, correct? We'll call this as y. Let this be equal to y. Let y be equal to this root of 8x minus x square minus 12. Okay. So my alpha becomes what? My alpha becomes equal to what? Alpha is x minus 7 the whole square. I call this as y. So this bracket will become y minus 4 the whole square. Okay, alpha, I want to find the minimum and maximum values of alpha now. So the given expression I wrote like this, call it as alpha, where you have to find the minimum and maximum values of alpha, and I call this expression root of as y. Okay, y is equal to root of a square minus x square represents the semicircle. Okay, semicircle it is. Here squaring on both sides, you get y square is equal to 8x minus x square minus 12. Okay, so from this we can complete the square, rearrange the terms, x square plus y square minus 8x plus 12 equal to 0. Completing the square for this, what we get is x minus 4 the whole square plus y minus 0 the whole square, y square. I am completing the square. I need to subtract 4 square, 16. So minus 16 plus 12, that becomes minus 4 equal to 4. Completing the square for this. Okay, I am subtracting 16 here because I take half of the coefficient of x minus 8, half into minus 8 minus 4. While completing the square, I need to subtract 16 here. So 4 square 16 minus 16 plus 12 minus 4 taken that side. This is representing a circle equation with center at 4, 0 and radius is 2. But this equation is a semicircle. This is of circle. By squaring on both sides, I got that. This is representing the semicircle with center at 4, 0 and radius is 2. Okay. This y is equal to root of 8x minus x square minus 12 represents what? It is representing the semicircle. Okay. Represents semicircle having center at 4, 0. Center is at 4, 0 and radius is 2. So something like this. 4, 0 is here, 2, 0 will be 6, 0 here, like this. This is semicircle. This point is 6, 0. This point is 2, 0. AB is the diameter of that semicircle, I can call. Okay, x-axis, origin and y-axis. Okay, y is equal to root of 8x minus x square minus 12 is a semicircle with center at 4, 0. 4, 0 is the center and radius is 2. Radius is 2 for this. 4, 0, I can mark this point as 4, 0. Okay. So midpoint of AB. 4, 0 is the center. Radius is 2. So radius is 2 of that semicircle. And I want to find the maximum and minimum values of alpha. Alpha is written like this. Alpha is here, correct? You want to find, concentrate on this. Want to find the minimum and maximum values of this alpha. So this alpha you can visualize it as like distance formula, square of the distance formula. Distance formula is what? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This alpha is representing square of the, because there is no square root here, correct? Square root is not there. So I can write alpha as root of x minus 7 the whole square plus y minus 4 the whole square. This alpha is what? Root of x minus 7 the whole square plus y minus 4 the whole square. Correct? This entire thing square. Correct? So alpha is representing square of the distance between the points x, y and 7, 4. 7, 4 is somewhere here. X, y is any point on the semicircle. Okay? X, y is what? It is any point on the semicircle because y is root of this. That is the equation of semicircle. So x, y is any point on the semicircle and 7, 4 is some point here outside the semicircle. So I want to find the minimum and maximum distance between the point 7, 4 and the point x, y on the semicircle. Okay. So when it becomes maximum and minimum, that you have to find out and square it. That is maximum and minimum values are named as capital M and small m. Capital M is the maximum value of alpha. So maximum value. When this distance between 7, 4 and a point on the semicircle becomes maximum and that you square it, that is M. So this is going to be the maximum distance, correct? You can mark this. This is your maximum distance. And the minimum distance is along the diameter or the radius, along the normal to the circle. This is a minimum value. Okay. So maximum is this. I'll call this point as P. So alpha maximum is possible when it is AP. AP gives the maximum value of alpha. So AP square. AP is distance between the points A and P. So maximum value of alpha is AP square. Okay. So when P want to find alpha maximum is maximum distance between the point P and a point on the semicircle. Where should be the point to become maximum value? The point A is maximum value. Distance between the point P and A is going to be the maximum, correct? So alpha is nothing but alpha max is max of alpha. Maximum value of alpha is what? AP square. AP the square. AP square is how much? AP is root of, correct? AP is root of 7 minus 2 the whole square plus 4 minus 0 the whole square. AP square. Square root and square will cancel. 7 minus 2 is 5. 5 square is 25 and 4 square is 16. This is your capital M. Capital M I got 41. Maximum value of alpha is capital M. Okay. Alpha is what? Square of the distance. Alpha is representing square of the distance between the point 7, 4 and any point on the semicircle. Minimum of alpha is going to be equal to, this is the minimum value of alpha, square. I need to find square of the distance. So the minimum distance between point x, y and a point on semicircle is this. This is the minimum, which is got by finding, I'll call C as the center of the semicircle, CP minus R. CP minus R the whole square, because square is there. CP is what? CP will be distance between 7, 4 and 4, 0. For that I need to find distance formula. Root of 7 minus 4 the whole square plus 4 minus 0 the whole square. CP, correct? Minus radius of the semicircle is 2. CP minus R the whole square. That is minimum value of alpha, correct? So 7 minus 4 is 3 here. 3 square is 9, correct? This becomes root of 9 plus 16 minus 2 the whole square. This will be root 25, which is 5. 5 minus 2 the whole square. 5 minus 2 is 3. 3 square is 9, which is equal to small m. Okay. So I got capital M and small m. Want to find capital M square minus small m square. Capital M is 41. 41 square minus small m is 9. So 9 square. 49 square is 1681. And 9 square is 81. So difference is 1600. Answer is 1600. Question asked on 5th of April, second shift, JEE Main 2024. Please make a note of this. So quite different question. Okay. We're not using the concept of derivative at all here. Just based on the geometrical figure. Based on the figure, we're finding the maximum value and the minimum value. CP is the minimum value. AP is the maximum value. They're finding square of the distance between the points x, y and 7, 4. 7, 4 is a fixed point here. X, y is any point on the semicircle. Where the minimum distance happens, we find out. Where the maximum distance happens, we find out. For this, the minimum distance is possible between 7, 4 and a point on semicircle. Correct? Find this is the minimum distance. Square of the minimum distance is alpha, minimum value of alpha. And square of the maximum distance is that is capital M. Square of the maximum distance is capital M. Square of the minimum distance is small m. Okay. So I am finding square of the maximum distance and square of the minimum distance as capital M and small m. Then finding capital M square minus small m square according to the question. Hope it's clear. Move on to the next one. The interval in which the function f of x equal to x power x is strictly increasing. Strictly increasing means derivative is greater than or equal to 0 I can use. Okay. Derivative of x power x we know, it's very standard. Given f of x is x power x. F of x is x power x. F dash of x. Derivative of x power x is x power x into 1 plus log x. Derivative of x power x. X power x into 1 plus log x. F is increasing. As f is increasing, we can use f dash of x is greater than or equal to 0. F is increasing implies f dash of x is greater than or equal to 0. So x power x into 1 plus log x is greater than or equal to 0. X power x is anyway positive because x is positive. So I need to have the condition that 1 plus log x should be greater than or equal to 0. 1 plus log x is greater than or equal to 0. So log x is greater than or equal to minus 1. So x is greater than or equal to e power minus 1. E power minus 1 is 1 by e. So x is greater than or equal to 1 by e. That means the interval is 1 by e to infinity. Function is strictly increasing in the interval. F is increasing in the interval or strictly increasing in the interval 1 by e to infinity. Greater than or equal to 1 by e. Correct? Strictly increasing in the interval 1 by e to infinity. Correct? X is greater than or equal to 1 by e is got. Convert the log form to exponential form. Base is e here. E is a number greater than 1. So inequality remains the same. Correct? If a number, the base is greater than 1, the inequality remains the same. Correct? Because it is an increasing function. Log is increasing function for base is greater than 1. And if the base lies between 0 and 1, the function log is going to be a decreasing function. Here the inequality remains the same. Okay? Because the base is e here. And learn the conversion from log to exponential. Log x base is greater than or equal to minus 1 means x is greater than or equal to e power minus 1. This is 1 by e. So this is 1 by e here. Correct? Greater than or equal to 1 by is this side. 1 by e to infinity. 1 by e to infinity this side. So answer is option C. Quite a simple question. Okay. Question answered on 6th of April, first shift, JEE Main 2024. Move on to the next one. Question number 7. Function f of x given as 1 by x to the power 2x. When x is greater than 0, attains the maximum value at x equal to 1 by e. Want to find which of the option is correct. F of x given as 1 by x power 2x. U power v form, where u and v are variables, functions of x. So you can use logarithmic differentiation and use derivative of u power v. Derivative of u power v is u power v into derivative of v log u. I'll be using this formula. Okay, from logarithmic differentiation. Derivative of u power v is equal to u power v into d by dx of v log u. Use this to find the derivative of 1 by x to the power 2x. F of x is given here. So f dash of x will be what? F dash of x is equal to 1 by x to the power 2x, 1 by x to the power 2x into d by dx of v log u, that is 2x log 1 by x, 2x log 1 by x is equal to what? 1 by x to the power 2x, and you can write log 1 by x as minus log x. We know this, log 1 by x. Log 1 by x is log 1 minus log x. Log 1 minus log x. Log 1 is 0. Correct? 0 minus log x, which is equal to minus log x. So log 1 by x is minus log x. You must know this. So this will be d by dx of 2x into log 1 by x is minus log x. I need to differentiate minus 2x log x. Minus 2x into log x. So this will be equal to 1 by x to the power 2x into 2 you keep outside. Minus 2 you can keep outside, minus 2. Differentiate x log x by using product rule. X into derivative of log x, which is 1 by x, plus log x into derivative of x is 1. F dash of x equal to 0 to get the critical point. Anyway, these terms outside the bracket doesn't become 0. So terms inside the bracket will become 0. 1x will cancel here. This is 0. Correct? This term will be equal to 0 means 1 plus log x should be equal to 0. 1 plus log x equal to 0 means log x equal to minus 1. Correct? Log x is equal to minus 1 means x is equal to e power minus 1. Converting log to exponential form. E power minus 1 is 1 by e. So if you want, you can find out the second derivative, f double dash, and evaluate the second derivative at x equal to 1 by e. You will get negative answer. Okay? And that confirms that second derivative is negative, means the function has maximum value at x equal to 1 by, it's already given. Of course, 1 by e is a critical point I'm getting. I use the f dash of x equal to 0 here to get the critical point. X equal to 1 by is the critical point. If you take a number line, okay, I'll take from x greater than 0, okay. So 0, I'll mark 0 here, and here it's 1 by e, and here it's infinity, okay. So between, if you take a number between 0 and 1 by e, 1 by e is roughly equal to 1 by 2.71828, almost 1 by 3 you can take. So you take a number, say 0.1, 0.1 lies in this, correct, between 0 and 1 by e. If you take 0.1 and evaluate, this value is going to be how much? Derivative is, anyway, this is positive, here it's negative. When you put x equal to 0.1, log of 0.1 is negative, it lies between 0 and, it's a negative value. 1 plus log is will be positive, correct? So 0 to 1 by e, 0 to 1 by e is how much? You can find out the derivative. They told the function is attaining maximum value at x equal to 1 by e. So if you take a values between 0 to 1 by e, or if you take a value say greater than 1 by, say you take x equal to 1 you take, log 1 is 0, correct. 1, when you put x equal to 1, f dash of x is, here it is positive, negative, here it is 1 plus log 1, putting x equal to 1, because 1 lies in the interval 1 by e to infinity. In this interval, I am taking the value of x as 1 and evaluate this, 1 plus log 1 is 0, 1 plus 0 is 1 into minus 2, here it is negative, here it is negative, here it is positive, correct. You can take a value say 0.1 and evaluate 0.1 plus 1 plus log of 0.1, okay, that will be negative. 1 plus log of 0.1 is going to be negative, negative into negative becomes positive. So in the interval 0 to 1 by the function is increasing. They told it as maximum value at 1 by. The graph of the function may look like this. The function increases from 0 to 1 by, the function is increasing. At 1 by it reaches the maximum value and again it decreases. Again it decreases. At 1 by it reaches the maximum value. Something like this. The function f of x has maximum value at x equal to 1 by e. Okay. So in the interval 0 to 1 by e, the function is increasing. And in the interval 1 by e to infinity, the function is decreasing. That is confirmed. So now clearly f is increasing in the interval 0 to 1 by e. F is increasing in the interval 0 to 1 by e. I need to compare the values of e power pi and pi power a according to the option. So using this concept of the function is given function 1 by x to the power 2x is increasing in the interval 0 to 1 by e. Increasing function concept I am going to use and find out whether e power pi is bigger or pi power e is bigger. So e is slightly less than 3, 2.71828. Pi is greater than 3, 3.14159. So e and pi, if we compare, e is less than pi, correct? We know that e is less than pi. We know that e is less than pi. This implies 1 by e is going to be greater than 1 by pi, correct? If you take the reciprocal, then the inequality is going to reverse. 1 by e and 1 by pi, if you compare, 1 by e is bigger. And both of them will lie in this interval 0 to 1 by e, correct? So 1 by e is going to be greater than 1 by pi. Both will lie in this interval 0 to 1 by. Of course, you can take the closed interval also, 0 open closed interval I can take. So 1 by e is greater than 1 by pi. And the function is increasing, right? Function is increasing means I can write x1 is greater than x2 implies f of x1 greater than f of x2, correct? For increasing function, for strictly increasing function, we can write like this. For strictly increasing function, x1 is greater than x2 implies f of x1 is greater than f of x2, correct? For strictly increasing function. So f of 1 by e is greater than f of 1 by pi. F of 1 by e is greater than f of 1 by pi. F of 1 by e is how much? F of 1 by e. F of x is here. F of x is 1 by x power 2x. F of 1 by e will be 1 by 1 by e power 2 by e. 1 by 1 by e becomes e then. Put x equal to 1 by e. So I'll get e power 2 by e. E power 2 by e is going to be greater than f of 1 by pi. F of 1 by pi is 1 by 1 by pi. That is pi. Pi power 2 by pi. Pi to the power 2 by pi. What we do is we'll take square roots on both sides. E power 1 by is greater than pi power 1 by pi. Okay. Now you raise it to the power pi for both of this. Raising to the power pi on both sides. Pi power 1 by pi is there. Raise it to the power pi e. What we get? E power 1 by e power pi becomes e power pi. Powers gets multiplied. Greater than pi power 1 by pi into pi becomes e. Pi cancels. Powers gets multiplied. So I'm getting the option B as answer. E power pi is greater than pi power e. Correct? E power pi is greater than pi power e. E is 2.71828, roughly equal to. Pi is approximately equal to 3.1415. Comparing e power pi and pi power e power pi is bigger. Using the concept of this function 1 by x power 2x is reaching maximum value at x equal to 1 by. In the interval 0 to 1 by, the function is increasing, reaches maximum, then decreases. So using the function is increasing in the interval 0 to 1 by, and comparing the values of 1 by e and 1 by pi. 1 by e is bigger than 1 by pi. So f of 1 by e is greater than f of 1 by pi, using the concept of increasing function. Increasing function means x value increases, or if x value decreases, even function value decreases. If x value increases, even function value increases. Your x1 greater than x2 implies f of x1 greater than f of x2. That concept is used. Strictly increasing function concept is used, and I'm deducing which is bigger. E power pi is bigger than pi power e. Option B is answer. Question asked on 6th of April, second shift, JEE Main 2024. Move on to the next one. Question number 8. For the function f of x given like this, between the following two statements, f of x equal to 0 for only one value of x in the interval 0 to pi, and statement 2 is given, f of x is decreasing in the interval 0 to pi, is, not in, not is, in it is, in the interval 0 to pi, for only one value of x in the interval 0 to pi. Okay. So, in the interval 0 to pi, f of x becomes 0 for only one value of x, and f of x is decreasing in the interval 0 to pi by 2, increasing in the interval pi by 2 to pi. Okay. So, find out whether it is true or not, statement 1 and statement 2. First, we will find the derivative of this. Given f of x equal to, given f of x is equal to how much? Cos x minus x plus 1. Cos x minus x plus 1. F dash of x. F dash of x is equal to derivative of cos x minus sin x. Derivative of minus x is minus 1. Derivative of 1 is 0. F dash of x. F of x is decreasing in the interval 0 to pi by 2. I'll verify statement 2 first. Whether it's decreasing in the interval 0 to pi by 2. Yes, sin x is positive in the interval 0 to pi by 2. So minus sin x is negative. So minus sin x minus 1 is less than 0 for all x belongs to the interval 0 to pi by 2. For all x belongs to the interval 0 to pi by 2. Derivative is less than 0 for all x. Correct? Therefore, function f is decreasing is true. F of x is decreasing in the interval 0 to pi by 2 is true. Derivative is less than 0. Correct? Function is decreasing in the interval 0 to pi by 2. So statement 2 is in the interval 0 to pi by 2 it's decreasing. What about in the interval pi by 2 to pi? That also I need to check. In the interval pi by 2 to pi, we can take 0 to pi directly because 0 to pi sine function is positive, right? So even in the interval pi by 2 to pi, the function is increasing only. Pi by 2 to pi, and even in the interval pi by 2 to pi, the function decreasing only because derivative happens to be negative. Also, I'll write also f dash of x equal to minus sin x minus 1 is less than 0 only because sin x is positive in the interval pi by 2 to pi, correct, greater than or equal to 0, sine function. So even minus sin x minus 1 happens to be negative for all x belongs to the interval pi by 2 to pi. Even in the second quadrant, sine function is greater than or equal to 0. So minus sin x will be negative. Minus sin x minus 1 definitely negative, correct? Minus of sin x plus 1 I can write. If you want, you can take minus of sin x plus 1. You can put a bracket like this and make sin x plus 1 like this. Here also. Minus of sin x plus 1. Sin x plus 1 is positive. So minus of sin x plus 1 is negative. In the first quadrant and second quadrant, in both the quadrants, the function derivative is negative. Therefore, function is decreasing only. Implies f of x is decreasing in the interval pi by 2 to pi as well. So in both the intervals 0 to pi by 2 and in the interval pi by 2 to pi, the function f is decreasing. Correct? In both the intervals 0 to pi by 2 and pi by 2 to pi, in both the intervals the function is decreasing. So statement 2 is incorrect. Statement 2 is incorrect. S2 is incorrect. Statement 2 is incorrect. Incorrect or not correct. Incorrect we can write. Is incorrect. Statement 2 is incorrect because in both the intervals the function is decreasing because derivative is negative or derivative is less than 0 in 0 to pi by 2 as well as in the interval pi by 2 to pi. What about the statement 1, f of x equals 0 for only one value of x in the interval 0 to pi. So in the interval 0 to pi, if you check, the function is decreasing, right? 0 to pi by 2 decreasing and pi by 2 to pi also decreasing. In both the intervals the function is decreasing. In both the intervals the function is decreasing. So we can conclude that we have f is strictly decreasing or f is decreasing in the interval 0 to pi, I can write. F is strictly decreasing, we can use. F is strictly decreasing in the interval 0 to pi. And the graph of the function, how it looks in the interval 0 to pi, roughly 0, pi by 2, pi. In the interval 0 to pi, the function is decreasing. And note that f of 0 and f of pi you find out. Note that f of 0 and f of pi is how much? At the end points, you find out the function value. F of 0 is how much? F of 0, put x equal to 0 and write cos 0 minus 0 plus 1. Cos 0 is 1, 1 minus 0 plus 1. F of 0 is 2. What about f of pi? F of pi is cos pi minus pi plus 1. Cos pi minus pi plus 1. Cos pi is minus 1. Minus 1 minus pi plus 1 is going to be equal to minus pi. Correct? Therefore, f of 0 is positive and f of pi is negative. F of 0 is how much? 2. Somewhere here, f of 0 is 2. F of 0 is 2. Above the x-axis. Correct? F of 0 is 2. Here it is. 0, 12. F of 0. And f of pi is minus pi, somewhere here. So graph is coming down, it is decreasing. Function is decreasing. So f of x equals 0 for only one value of x in the interval 0 to pi is true. Correct? Because the function is decreasing and f of 0 is positive and f of pi is negative. F of 0 into f of pi is negative. The product of these two is negative. Product f of 0 into f of pi is negative. Therefore, I can conclude that the function f of x equal to 0 has only one value in the interval 0 to pi. That means it crosses the x-axis only once. Because the function is decreasing, f of x equal to 0 is possible for only one value of x. So, statement 1 is true. Correct? Because f of 0 is positive and f of pi is negative and the function is strictly decreasing in the interval 0 to pi. It crosses the x-axis only once. It can't come down and go up like this. If the function is say decreasing in the interval 0 to pi by 2, then again increases, it comes down like this, then some point it is reaching minimum and again it becomes increasing, then the function will cross the x-axis at 2 points. Correct? Here, because the function is strictly decreasing, it comes down like this in the interval 0 to pi, the function decreasing only, it can't cross the x-axis again, only once it crosses the x-axis. And f of 0 is positive, it is above the x-axis, f of pi is negative. So all these conditions satisfied. F of 0 is positive, means it is above the x-axis. F of pi is negative, means below the x-axis, and it crosses the x-axis there. Correct? Only 1 point because the function is decreasing. So statement 2 is correct. Statement 1 is correct. Statement 2 is incorrect. Statement 2 is incorrect. Statement 1 is correct. So only statement 1 is correct. Only statement 1 is correct. Statement 2 is incorrect. Statement 1 is correct. Statement 2 is incorrect as we got here. Statement 2 is incorrect. Statement 1 is correct. Only statement 1 is correct. Option D is the answer. 8th of April, first shift, JEE Main 2024. This was the question. Move on to the next one. Given function f of x equal to 4 cos cube x plus 3 root 3 cos square x minus 10. Number of points of local maxima of the function in the interval 0 to 2 pi. So we use the concept of local maxima. How many points of local maxima are there to find out? Find out f dash of x here. F dash of x. F dash of x is equal to, differentiate and write, 4 into derivative of cos cube x, 3 cos square x into derivative of cos x, which is minus sin x. Correct? Using chain rule. Constant into variable. Constant keep as it is. Derivative of cos square x. Derivative of cos square x is 2 cos x into derivative of cos x is minus sin x. And derivative of 10 is 0. I'm getting like this. F dash of x. Need to find the critical points where f dash of x becomes 0. We can take common terms here. Cos into sin is common. Also 3 into 2, 6 is common. This is actually minus 12 cos square x into sin x. Minus 12 cos square x into sin x. 3 into 2 becomes 6. Plus into minus and minus there. Minus 3 2 is 6. 6 root 3 into cos x into sin x. You can take common here. What is common here? Common is minus 6 cos x sin x. Minus 6 cos x into sin x is common. Correct? What remains is 2 cos x plus root 3. Minus 6 cos x into sin x is out. What remains is 2 cos x plus 3. F dash of x equal to 0 to get the critical points. So cos x equal to 0. Minus 6 can't be 0. Cos x equal to 0, one possibility. Cos x equal to 0 means x equal to pi by 2 and 3 pi by 2 in the interval 0 to 2 pi, correct? Cos x will become 0 for x equal to pi by 2 and x equal to 3 pi by 2. Sin x equal to 0. Sin x will equal to 0 for x equal to n pi. In this interval 0 to 2 pi, open interval, only possibility is x equal to pi. 2 cos x plus root 3 is equal to 0, means cos x equal to minus root 3 by 2. Cos x is minus root 3 by 2. That is possible. Cos function is negative in the second quadrant and in the third quadrant. So pi minus pi by 6, 5 pi by 6 and 7 pi by 6. 5 pi by 6 and 7 pi by 6. 150 degree and 210 degree. Second quadrant and third quadrant respectively. So these are the critical points I'm getting. Where f dash of x equal to 0, possibilities I'm writing. 5 values of x I'm getting. So in which all lie in the interval 0 to 2 pi. So I'm using the first derivative test to find the points of local maxima. Local maxima means what? According to first derivative test, f dash of x sign should change from positive to negative. Okay, then that point is the point of local maxima. As x passes through that point C is the point of local maxima. F dash of x changes the sign from positive to negative. So these are the 5 critical points I'm getting. So you can mark these critical points and find out the derivative sign. So the derivative sign changes from positive to negative or negative to positive. In the interval 0 to 2 pi we're discussing. So 0 is here. Smallest among this is pi by 2. Pi by 2, then comes 5 pi by 6. Then we have pi. Then we have 7 pi by 6. Then we have 3 pi by 2. Then we have 2 pi, correct? 3 pi by 2. Finally, we have 2 pi. So we want in the interval 0 to 2 pi. The 5 critical points are marked here. 0 to pi by 2 is first quadrant, correct? First quadrant, sine function is positive, cos function is positive, 2 cos x plus root 3 also positive, but negative. So negative is there, minus sign. Pi by 2 to 5 pi by 6. We take a convenient point, say 3 pi by 4. 3 pi by 4 you take. Sine 3 pi by 4 is positive because 3 pi by 4 is second quadrant. Second quadrant sine function is positive. Cos 3 pi by 4 is negative, minus 1 by root 2. Minus into minus will become plus there. Correct? So this will become plus. And cos x is minus 1 by root 2. Then you put 3 pi by 4. This is 1 by root 2. This is minus 1 by root 2. Minus into minus become plus. Outside the bracket it has become positive. Negative, negative, positive. So this product is positive. Here when you put x equal to 3 pi by 4, cos 3 pi by 4 is minus 1 by root 2. Minus 1 by root 2 into 2. That will be minus root 2. Minus root 2 plus root 3 is positive because root 3 is bigger than root 2. Root 3 minus root 2 is positive. So positive, positive, negative, negative. So negative into negative, positive, positive into positive, positive. I am getting positive here. Between 5 pi by 6 to pi, that is 150 to 180 degree. In that interval you take 165 degree. Say 165 degree you take. In terms of degrees is better, convenient. Sine 165 is same as sine 15, positive. And cos 165 is minus cos 15. Minus into minus will become plus here. So outside the bracket it is becoming plus. And here cos 165 is minus cos 15. Minus cos 15 into 2. Minus 2 into cos 15 plus root 3. That is going to be negative. Cos 15 is root 3 plus 1 by 2 root 2. Okay. That is multiplied by minus 2. That value will be negative. Minus 2 into root 3 plus 1 by 2 root 2 plus root 3. If you calculate it is negative. Okay. That you can find out. It will be negative. And in the interval pi to 7 pi by 6, you can take a value say 195 degree. Sine 195 is negative. Cos 195 is negative. Negative into negative, positive. Positive into negative, negative. This becomes negative. And sine cos 195 is minus cos 15. That will be, this quantity will be negative only. So I'll get negative, 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 negative. That becomes positive, correct? Negative, negative, negative. Both are negative. Negative into negative is positive. Positive into negative, negative. This is also negative. So the product becomes positive. 7 pi by 6 to 3 pi by 2. We can take a value say 240 degree. 4 pi by 3 lies in this interval. 240. Sine 240 is negative. Cos 240 is negative. Negative into negative into negative is negative. Correct? And here what you get is cos 240 is minus half. Minus half into 2 is minus 1. Minus 1 plus root 3 is positive. Positive, negative, negative, negative. So product is negative. And in the interval 3 pi by 2 pi, you can take a value say 300 degree. 5 pi by 3. 5 pi by 3 lies in this. Or you can take 330 also. Any value. 300 I'll take. Cos 300 is positive. Sin 300 is negative. Negative into positive into negative is positive. And here cos 300 is minus half. Minus half into 2. That is minus 1. Minus 1 plus root 3 is positive. So it becomes positive here. Okay. So you can take the values of x in that interval and verify whether f dash of x is negative or positive. And see the derivative sign changes here. At pi by 2 it is changing from negative to positive. So local minima. F dash of x changes sign from negative to positive is local minima. At 5 pi by 6 derivative sign changes from positive to negative. So local maxima. At pi negative to positive. So local minima. Pi at 7 pi by 6 derivative sign changes from positive to negative. So local maxima. At 3 pi by 2 derivative sign changes from negative to positive. Local minima. So they asked to find number of points of local maxima. So f dash of x, f has local maxima at 2 points. One is at 5 pi by 6, another at 7 pi by 6. F has local maxima at x equal to how much? One is at 5 pi by 6 and x equal to 7 pi by 6. Because at these 2 points, derivative sign changes from positive to negative according to the first derivative test. Because at x, as x passes through these points, as x passes through 5 pi by 6 and 7 pi by 6. As x passes through 5 pi by 6, what happens? F dash of x changes the sign from positive to negative. Changes the sign from positive to negative. Changes the sign from positive to negative. Same thing happens even at 7 pi by 6. Derivative sign changes from positive to negative. Correct? As x passes through the point 7 pi by 6. F dash of x changes the sign from positive to negative. Changes the sign from positive to negative. These are the points of local maxima. 5 pi by 6 and 7 pi by 6 are the points of local maxima. Number of points of local maxima is 2. Other points, pi by 2, see it's a local minima, negative to positive. At pi by 2, negative to positive. At pi also negative to positive. At 3 pi by 2, negative to positive. The 3 points of local minima, pi by 2, pi and 3 pi, they are the points of local minima because derivative sign changes from negative to positive, negative to positive, negative to positive. When it changes from positive to negative, that is local maxima. Correct? Positive to negative here. At 5 pi by 6, derivative sign changes from positive to negative. At 7 pi by 6, derivative sign changes from positive to negative. It's a point of local maxima. So x equal to 5 pi by 6 and 7 pi by 6 are the points of local maxima. There are 2 points of local maxima. Are points of local maxima according to the question asked. As number of points of local maxima in the interval 0 to 2 pi is 2. There are 2 points of local maxima. Question asked on 8th of April, first shift, JEE Main 2024. Move on to the next one. Number of critical points of this function to find out. Given like this, x minus 2 power 2 by 3 into 2x plus 1. Number of critical points where f dash of x vanishes, where f dash of x not defined. Such points are critical points. So differentiate this by using the product rule. F of x is given like this. X minus 2 to the power 2 by 3. X minus 2 to the power 2 by 3 into 2x plus 1. This implies f dash of x is equal to, apply the product rule. First function keep as it is. Differentiate the second function. Derivative of 2x plus 1 is 2. Plus second function keep as it is. Differentiate the first function. Derivative of x minus 2 power 2 by 3 is x minus 2 by 3 into x minus 2 to the power 2 by 3 minus 1, which is minus 1 by 3 into derivative of x minus 2 is 1. You can simplify this. 2 into x minus 2 to the power 2 by 3 plus 2x plus 1 into 2 divided by, this you bring it to denominator, 3 into x minus 2 to the power 1 by 3. So this is common denominator, 3 into x minus 2 to the power 1 by 3, correct, divided by 1. Correct, what I am going to get, 1 into this into that. So 2 into 3 will be 6. X minus 2 power 2 by 3 into x minus 2 power 1 by 3. That becomes x minus 2 to the power 1. Bases are same, add the powers. Correct. And 2 into 2x plus 1. 2 into 2x plus 1. F dash of x I am getting like this. Which is equal to 6x minus 12 plus 4x plus 2. Divided by 3 into x minus 2 to the power 1 by 3, which simplifies to 10x minus 10, correct, divided by 3 into x minus 2 to the power 1 by 3. Where f dash of x becomes 0, numerator should become 0. Numerator by denominator is 0 means numerator equal to 0. F dash of x equal to 0 implies numerator should be 0. Now, f dash of x equal to 0 implies numerator should be equal to 0. Numerator by denominator is 0 means numerator equal to 0. Numerator is 10x minus 10. 10x minus 10 equal to 0 implies x equal to 1. It's a critical point. Also, f dash of x is not defined. It gives you a critical point. Denominator is 0 means f dash of x is not defined. F dash of x is not defined when denominator is 0. F dash of x is not defined for denominator equal to 0. Not defined for denominator equal to 0. X minus 2 equal to 0. X minus 2 equal to 0 means x is equal to 2. So x equal to 1 is a critical point. X equal to 2 is a critical point because for x equal to denominator is 0. Denominator is 0 means derivative is not defined. Derivative is not defined is also a critical point. Derivative vanishes also becomes a critical point. Our number of critical points is 2. Correct? 1 and 2. Therefore, number of critical points is 2. number of critical points, number of critical points is 2. Move on to the next one. Question number 11. Function f of x again like this has a local maximum at x equal to alpha and a local minimum at x equal to alpha square. Alpha and alpha square are the roots of which equation you have to find out. F of x given like this is a polynomial of degree 3. Differentiate it. F of x is given to us like this 2x cube minus 9ax square 9ax square plus 12a square x plus 1. F dash of x how much? F dash of x is equal to 6x square minus 9a into 2x 18ax. Derivative of 12a square is 12a square. Derivative 12a square x is 12a square. Derivative 1 is 0. Find out the critical points. Now f dash of x equal to 0 I find out. F dash of x equal to 0. 6 is common there. F dash of x equal to 0. 6 if you take common, what you get is x square minus 3ax plus 2a square is equal to 0. 6 is not equal to 0. So x square minus 3ax plus 2a square equal to 0. Terms inside the bracket equal to 0. You can factorize this as x minus a into x minus 2a. X minus a into x minus 2a equal to 0. Which gives x equal to a, x equal to 2a as the critical points. Also you find out f double dash of x. F double dash of x. Derivative of 6x square is 12x. Derivative of 18ax is 18a. Derivative of constant is 0. Now f double dash of a. Second derivative at x equal to a because a and 2 are the critical points. 12a minus 18a which is equal to minus 6a. Minus 6a is negative because I told a is positive. Correct? A is positive given in the question. A is positive. And you find out the second derivative at x equal to 2a. When you put x equal to 2a, 12 into 2 is 24a minus 18a which is equal to 6a. 6a. Second derivative is 6a. That is positive because a is positive. According to the question, local maximum at x equal to alpha, local minimum at x equal to alpha square. Okay. So local maxima is possible at x equal to a because second derivative is negative. By using second derivative test, points of local maxima is where first derivative should be 0 and second derivative should be negative for local maxima. For second derivative to be negative, it becomes local maxima. At x equal to a, second derivative is negative. So x equal to a is point of local maxima. X equal to a is the point of local minima because second derivative is positive. First derivative is 0 and second derivative is positive, local minima. So according to this, x equal to a is the point of local maxima. At x equal to a, f as local maxima because at x equal to a, first derivative is 0 and second derivative is negative. So f is local maxima at x equal to a. And at x equal to 2a, the function has local minima. X equal to 2a, the function has local minima because at x equal to 2a, what we have, the first derivative is equal to 0 and second derivative is positive at x equal to a condition for local minima according to second derivative test. So according to the question, local maxima at alpha, local minima at alpha square. So alpha and alpha square are the roots of which equation? So we can form the quadratic equation using roots as alpha and alpha square. So quadratic equation will be what? Roots as alpha and alpha square. The quadratic equation is going to be x square minus alpha plus alpha square into x. Correct? X square minus sum of the roots into x plus product of the roots equal to 0. Correct? So what we have is x square minus of alpha plus alpha square into x plus alpha cube is equal to 0. According to this, a and 2a, correct? A and 2a is the point of local maxima, 2a is the point of local minima. So I can put alpha as a and alpha square as 2a. What do we get? X square minus, put alpha as a and alpha square as 2a. Alpha as a and alpha square as 2a. A into 2a equal to 0. Putting alpha as a and alpha square as 2a. So what I am going to get from this? This will be x square minus 3ax plus 2a square is equal to 0. Which is satisfied for a is equal to 2. Option A satisfies. Correct? Option A satisfies for a is equal to 2. For a is equal to 2. Option A is satisfied. X square minus 3 into 2 6x plus 2 into 2 square. 2 square is 4. 4 into 2 8 equal to 0. For a equal to 2, option A is satisfied. So option A is the answer. Question answered on 8th of April, second shift, JEE Main 2024. Move on to the next one. Let A be the region enclosed by the parabola y square is equal to x and the line x equal to 24. The maximum area of the rectangle inscribed in the region A is on it. Numerical type question asked. Y square is equal to x is a parabola, you know. So equation of parabola. Y square is equal to 2x. Having axis along x-axis. Symmetric with respect to x-axis and vertex is at origin. This is the parabola. Y square is equal to 2x. And the line x equal to 24 is a vertical line. X equal to 24. X equal to 24. Y square is equal to 2x. The parabola and the line x equal to 24. Maximum area of the rectangle inscribed in the region A you have to find out. So we'll inscribe a rectangle inside this region, okay, and want to maximize it. Rectangle is inscribed in the region A. Region A is this. Area bound by the parabola y square is equal to x and the line x equal to 24. So if you inscribe a rectangle here, like this. Want to find out this maximum area of this. Area of this rectangle you have to find out maximum area. What we'll do is we'll take the y coordinate of this point. Let the length be equal, let the breadth of this rectangle be b, and this point will be because this is a vertical line, all the points on this line will satisfy x equal to 24 because equation of vertical line is x equal to constant. It's a vertical line, correct? This point is 24 comma b. I'll call this 24 comma b. We call this rectangle as ABCD. ABCD, okay, rectangle. This point is B here. A, B, C and D. A, B, C, D is a rectangle. Point B is B comma 24. Point A we can find out. Point A is what? Because I've taken the breadth of this, not breadth, the value of y I've taken as B. Okay, value of y is B. Okay, this much is B. This much is B. So the point A will be, A is the point on the parabola, correct? So I've taken the y coordinate as b here. So y square, y is b. So x will be b square by 2. Point A will be b square by 2, comma b. Correct? X is b square by 2. X is y square by 2. Y is b. So point A is b square by 2, comma b. And point B is 24, comma b. Point C we can find out similarly. Okay. Point C and point D I can write down. Point C is a reflection of the point B, correct? It will be 24 comma minus B. And point D is what? B square by 2 comma minus B. Like this. Area of the rectangle is what? Length into breadth. Length I can find out. Length is BC and the breadth is CD, correct? Area of the rectangle is length into breadth. We want to find the maximum area of this rectangle. Area of the rectangle is length into breadth. Length into breadth. Length is how much? Length is BC. BC is how much? This much is B. This much is B. B plus B is 2B. Length is 2B. And the breadth is how much? Breadth is this much, same as CD. CD you have to find out, that is same as this. This will be equal to 24 minus B square by 2, correct? CD is same as, I'll call this as MN. CD is same as MN, right? CD is same as MN. MN is ON minus OM. ON minus OM. What is ON? ON is 24, correct? And OM is how much? OM is B square by 2, correct? From here to here it is B square by 2. So CD is nothing but the breadth. Breadth is 24 minus B square by 2. Multiply this and differentiate with respect to B. 2 into 24, that is 48B minus 2 cancels. B into B square becomes B cube. Differentiate with respect to B. Differentiate with respect to B. What do you get? dA by dB. Differentiating with respect to B. Derivative of 48B is 48. Derivative of B cube is 3B square. Again differentiate. D square A by dB square. Second derivative. Derivative of 48 is 0. Derivative of 3B square is 6B minus 6B. First derivative equal to 0. That means B square is equal to 16. B square is 16. B is equal to plus or minus 4. I'll take B equal to 4. Taking positive value. B is positive. Okay. So that second derivative is negative. Correct. When B equal to 4, second derivative is negative. Therefore, area is maximum. When B equal to 4, second derivative is negative. D square A by dB square. Second derivative is equal to how much? Minus 6 into 4. Minus 24, which is negative. That means second derivative is negative, means it confirms that the maximum value is possible when B is equal to 4. Area is maximum when B equal to 4. Find out the maximum area. You can substitute in this. A max you can find out by putting B is equal to 24 in this. B is equal to 4 in this. Put B is equal to 4 to get A max. Therefore, A max is got by putting B is equal to 4. A max is got by putting B is equal to 4. 48 into 4 minus 4 cube. 48 into 4 how much? 192. 4 cube is 64. This becomes 128. Maximum area of this rectangle in the region is 128 square units. Okay. Put B is equal to 4 to get the maximum area of the rectangle. Correct. And B is equal to 4. First derivative is 0 and second derivative is negative for area to become maximum. Conditions for maximum is satisfied. Question asked on 8th of April, second shift, JEE Main 2024. Move on to the next one. A variable line L passes through the point 3, 5 and intersects the positive coordinate axis, the points A and B. Minimum area of the triangle OAB are defined, where O is the origin. So variable line is there, intersects the positive coordinate axis, x axis and y axis. Coordinate axis, positive coordinate axis at the points A and B. At the points A and B. Okay. So A is x-intercept, I can call this as A, x-intercept is A and y-intercept is B, correct? You can use the intercept form and the variable line is passing through the point 3, 5, point P is there, 3, 5. It passes through the point 3, 5, the variable line. So take the equation of line in the intercept form. Line is, the variable line is L is x by A plus y by B equal to 1. It passes through the point 3, 5, correct? It passes through the point 3, 5. Substitute x equal to 3, y is equal to 5. It passes through 3, 5. So substitute x equal to 3, y is equal to 5. 3 by A plus 5 by B is equal to 1. Correct? 3 by A plus 5 by B equal to 1. From this, I want to find the minimum area of this triangle. Area of the triangle OAB is half into x-intercept into y-intercept because it's a right angle triangle, correct? So x-axis perpendicular to y-axis, we know. So it's a right angle triangle. Area is going to be equal to half into AB, half into base into height. Base is x-intercept and height is y-intercept. So area of the triangle OAB is half AB. Okay, it passes through the point 3, 5. So from this we eliminate B here. What is 5 by B from this? 5 by B is equal to 1 minus 3 by E. Okay, take LCM from this, get A minus 3 divided by 3, or from this B is equal to how much? B is equal to, A minus 3 divided by A minus 3 divided by A, taking LCM A. So B is equal to how much? B is equal to 5A divided by A minus 3, correct? From this B is equal to 5A divided by A minus 3. Area of the triangle is half AB. Area of triangle AOB. A is equal to half into base into height. So half into base into height is, I'm getting 5A divided by A minus 3. So this will be equal to how much? 5 by 2 is constant, keep outside. A square divided by A minus 3, we can write like this. We want to find the minimum area of this triangle. A minimum we have to find out. We can minimize this by using the concept of derivatives. Using the derivative test also we can do. First derivative equal to 0 and second derivative should be positive for area to become minimum. That is one concept. Whenever minimum value is asked, what is strikes for you is the concept of EM-GM inequality. One of the most familiar concepts. Arithmetic mean greater than or equal to geometric mean is quite useful. When geometric mean becomes independent of variable, we can find the minimum value of certain expressions. So I'll be using that concept of EM-GM inequality here. So to find to apply EM-GM inequality, what I'm going to do is I'll make some modifications here. What I'm going to do is 5 by 2 keep as it is. In the numerator, what we do is add and subtract 9 here. A square minus 9 plus 9 divided by A minus 3. Divided by A minus 3, add and subtract 9 then. Okay, A square minus 9 we can write A minus 3 into A plus 3, factorize it, simplify this further, is equal to 5 by 2 into, what we have is A minus 3 into A plus 3 plus 9 divided by A minus 3. I want to use EM-GM inequality, otherwise you can use the method of differentiating also and get the critical point and find out the second derivative to be positive for area to become minimum. That way also we can do. Okay. So here I am using this concept, want to use EM-GM inequality to find the minimum value of this so that I get the minimum area of the triangle AOB. So A square is, in the numerator, add and subtract 9. A square minus 9, you factorize it, A minus 3 into A plus 3. Separate the terms, A minus 3 is going to cancel. Therefore, I am getting area is equal to, therefore right here, area is equal to, area what I am getting is 5 by 2 into A plus 3, A minus 3 cancels, correct, A plus 3 plus 9 by A minus 3, separating the terms, divide individually. Here what I'll do is I'll write A plus 3 as A minus 3 plus 9. Correct? Because I want to A plus 3, I'll write A minus 3 plus 6. So that expressing this in terms of A minus 3. Note that A plus 3 could be written as A minus 3 plus 6. Okay. So this is equal to 5 by 2 into this is A minus 3 plus 9 divided by A minus 3, okay, plus 6. So that A minus 3 plus 6 will be A plus 3. For this we apply EM-GM inequality. To apply EM-GM inequality, I told that geometric mean should become independent of variable. If you find geometric mean of A minus 3 and 9 by A minus 3, it becomes root 9, which is 3. So A minus 3 is cancelling here, correct? So I am using AM greater than or equal to GM. Arithmetic mean greater than or equal to geometric mean to find the minimum value. Okay. Arithmetic mean of A minus 3 and 9 by A minus 3. A minus 3 plus 9 by A minus 3. Arithmetic mean greater than or equal to geometric mean. Arithmetic mean is A plus B by 2. Greater than or equal to geometric mean is root of A minus 3 into 9 by A minus 3. A minus 3 cancels. Root 9 is 3. 3 into 2 is 6. So what you get is a minus 3 plus 9 by a minus 3. Root 9 is 3. 3 into 2 is 6. Correct? Arithmetic mean greater than or equal to geometric mean. Cross multiply. A minus 3 got cancelled. Root 9 is 3. 3 into 2 6. So greater than or equal to 6 means minimum value 6. An expression is greater than or equal to 6 means minimum value of this expression is 6. So minimum value of this expression is 6. I am getting a minimum from this. A minimum is got by putting this value, whatever underlined here, no, using this value minimum is 6. So what I get, minimum value is 5 by 2 into 6 plus 6. So what I am getting is 5 by 2 into 6 plus 6 is 12. 5 into 12, 60 by 2, 30 is the answer. So 30 is the minimum value of this. 2 ones are 2, 6, 6 into 5 is 30. Minimum area of the triangle is 30 square meters. Question asked on 9th of April, first shift, JEE Main 2024. Using intercept form of the line and it passes through the point 3, 5, eliminate one of the variable. A and B are the two variables here. Correct? So B is 5A by A minus 3, expressing B in terms of A. And maximize, I want to find the minimum value of area of triangle AOB, half into A into B. Area of triangle is half into base into height. Using that we got B is 5A by A minus 3. Substitute, eliminate B, express in terms of A, and use AMGM inequality here, shown here, steps, and area of the triangle minimum value is got here. 30 is the answer. Okay. Move on to the next one. Question number 14. Set of all positive values of lambda for which the point of local minimum of the function satisfies this. So find the point of local minima for this function, and that point is going to satisfy this inequality. So that is given to be the interval alpha beta. Want to find alpha square plus beta square. Call this function as f of x. F of x is equal to 1 plus x into lambda square, open the bracket, x into lambda square minus x cube. F dash of x. F dash of x is equal, derivative of 1 is 0. Derivative of lambda square into 1. Derivative of x cube is 3x square. Correct? Constant into variable. Constant keep as derivative of x1. Derivative of x cube is 3x square. Also you can find f double dash of x. F double dash of x. Derivative of lambda square is 0. Derivative of 3x square is 6x minus 6x. Now f dash of x is equal to 0. F dash of x is equal to 0. To get the critical points, lambda square minus 3x square is equal to 0. That means lambda square is equal to 3x square. So x square equal to lambda square by 3. X square is lambda square divided by 3. That means x is equal to plus or minus lambda by root 3. So want to find the point of local minimum. So second derivative should be positive for local minimum. So critical points are lambda by root 3 minus lambda by root 3. Second derivative when x is lambda by root 3, second derivative should be positive, right? So when x is minus lambda by root 3, what is f double dash of x? Minus 6 into x is minus lambda by root 3 will become 6 lambda by root 3, which is positive because they told lambda is a positive value, correct? Because lambda is positive, 6 lambda by root 3 is positive. So x equal to minus lambda by root 3, second derivative is positive, therefore it's minimum. At x equal to minus lambda by root 3, f as local minima. X equal to minus lambda by root 3, f as local minima. Function as local minima at x equal to minus lambda by root 3. This value of x is going to satisfy this inequation. So x square plus 2 by x square plus 5x plus 6 should be less than 0. It's given like this. We know that x square plus x plus 2, the numerator is always positive because b square minus 4ac is negative. A quadratic is definitely positive if coefficient of x square is positive and b square minus 4ac is going to be negative. If we consider x square plus x plus 2, x square plus x plus 2, it is always positive for all x belongs to R. because coefficient of x square is positive, coefficient of x square is positive, and b square minus 4ac is negative. Coefficient of x square is positive and b square minus 4ac is how much? 1 minus b is 1 square 1 minus 4 into a into c, which is 1 minus 8 minus 7, which is less than 0. Correct? So when b square minus 4ac is negative, roots are imaginary and coefficient of x square is positive, then the quadratic is positive for every real number. So numerator is already positive for every real number. So numerator but denominator should be less than 0 means denominator should be less than 0 because numerator is already positive. Positive by negative is negative. So denominator should be negative. So for this inequality to be satisfied, we have x square plus 5x plus 6 should be less than 0. So if x square plus 5x plus 6 should be less than 0 means I can factorize it, x plus 2 into x plus 3, correct? X plus 2 into x plus 3 should be less than 0. By using Baby-Cow method, I can get that x should belong to the interval minus 3 to minus 2. X should belong to the interval minus 3 to minus 2. Using x minus a into x minus b less than 0. X belongs to the interval ab. Minus 3 is smaller than minus 2. So x plus 2 into x plus 3 is less than 0. You can find the critical points and mark on the number line and find out. Or else directly using x minus a into x minus b less than 0. X minus a into x minus b is less than 0 means x should belong to the interval ab. You can use this concept. A is a smaller number than b. Okay. You can write this as x minus minus 3 into x minus minus 2. So that if you compare with this, I'll get the interval where this product is negative is for x belonging to the interval minus 3 to minus 2. So that is our interval minus 3 to minus 2. That value of x is satisfied in this interval. The point of minima, local minima for this function satisfies this inequation. Means the point of minima is x equal to minus lambda by root 3. That is going to satisfy this interval. So minus lambda by root 3 should lie between minus 3 and minus 2. Okay. Set of all positive values of lambda for which the point of minimum satisfies this is the interval alpha beta. Find alpha square plus beta square. So point of minima occurs when x equal to minus lambda by root 3. By second derivative test I confirm. Because when x equal to minus lambda by root 3, first derivative is 0. Correct? First derivative is 0 and second derivative is positive. When you put x equal to minus lambda by root 3, first derivative is 0 and second derivative is positive. Because lambda is positive, 6 lambda by root 3 is positive. Correct? So minus lambda by root 3 is the point of minima according to second derivative test. And this minus lambda by root 3 should satisfy this interval value of x. So x, this quotient is less than 0 for x belonging to interval minus 3 to minus 2. In that interval, the minus lambda by root 3 should lie. We can multiply the entire inequation by minus 1. If you multiply by minus 1, inequality is going to reverse. 3 is greater than lambda by root 3 is greater than 2. And you multiply by root 3 now. So multiplying by root 3, I'll write smaller number first. 2 root 3 is less than lambda less than 3 root 3. That means lambda belongs to the interval 2 root 3 to 3 root 3. Lambda belongs to the interval 2 root 3 comma 3 root 3, which is the interval a alpha beta according to the question. So I got the values of alpha and beta. Therefore alpha is equal to 2 root 3 and beta is equal to 3 root 3. Want to find alpha square plus beta square. Correct? 2 root 3 square. 2 square is 4. Root 3 square is 3. 2 root 3 square is 12. And 3 root 3 square is 27. So 27 plus 12, answer is 39. 39, numerical type question. Use various concepts here. Point of local minima you find out, and also you must know the quotient of these two is negative. Numerator is already positive because b square minus 4ac is negative and coefficient of x square is positive. Quadratic is positive if discriminant is negative and coefficient of x square is positive. Quadratic is negative if coefficient of x square is negative and b square minus 4ac is negative. Both coefficient of x square and b square minus 4ac are negative. Quadratic is negative. Quadratic is positive if coefficient of x square is positive and b square minus 4ac is negative. So that is a concept used here. Numerator is always positive, means it is positive for every real number, and denominator should be negative for that quotient to be negative. So x square plus 5x plus 6 less than 0, factorize it, x plus 2 into x plus 3 less than 0, x should belong to interval minus 3 to minus 2. You can obtain using this method. X minus a into x minus b is less than 0, means x belongs to the interval ab where a is smaller than b. Okay, so otherwise you can use the Vevicom method, mark the critical points as minus 3 and minus 2, right side you start. Okay, so many times I taught that Vevicom method in many of the problems. Okay, minus 3 and minus 2 is marked like this, minus 3, minus 2, right side of minus 2 is positive, and minus 2 is got from this, power of x plus 2 is one odd number sign changes, minus 3 is got from x plus 3 to the power 1 odd number, again sign changes, becomes plus. So where it is negative in the interval minus 3 to minus 2. This product happens to be negative in the interval minus 3 to minus 2. The value of lambda, the value of point of minima should satisfy this. So that you find the value of lambda. Lambda belongs to this interval 2 root 3 to 3 root 3. So find alpha square plus beta square. Numerical type question asked on 9th of April, first shift, JEE Main 2024. Move on to the next one. Set of all values of p for which the function f of x given like this does not have any critical point with the interval ab. Find 16ab. Numerical type question. So the function does not have any critical point, means f dash of x is not equal to 0. Okay, for any value of x, f dash of x is not equal to 0. That is a concept. So we can simplify one step here. Sine square theta minus cos square theta is minus cos 2 theta. Cos square theta minus sine square theta is cos 2 theta. No, cos square theta minus sine square theta is cos 2 theta. So what is present here inside the bracket is sine square theta minus cos square theta. Sine square theta minus cos square theta is going to be minus cos 2 theta. Correct? So I'll simplify the function f of x and write sine square 2x minus cos square 2x is minus cos 4x. Correct? Sine square 2x minus cos square 2x is equal to minus cos double angle 2x double is 4x minus cos 4x. I'll be using this. Okay, so my function f of x is simplified, right? F of x is equal to p square minus 6p plus 8, p square minus 6p plus 8 into sine square 2x minus cos square 2x is minus cos 4x plus 2 into 2 minus px, 2 into 2 minus p into x plus 7. Correct? Differentiate this. F dash of x. P is a constant here. P square minus 6p plus 8 is constant. F dash of x you find out. Derivative of cos is minus sine. Already there is minus of minus plus. Sine 4x into 4. So 4 sine 4x. Constant into variable. Constant keep as it is. Derivative of x is 1. And derivative of 7 is 0. Correct? Does not have any critical point. F has no critical point. Given F has no critical point. Implies f dash of x is not equal to 0. F has no critical points. Implies f dash of x is not equal to 0. F dash of x is not equal to 0. You can factorize this. This is p minus 2 into p minus 4, correct? This is p minus 2 into p minus 4, correct? Into 4 sine 4x is equal to, this is shifted to right hand side, f dash of x not equal to 0, no? So not equal to 2 into 2 minus p is taken that side, becomes 2 into p minus 2. 2 into p minus 2, f dash of x not equal to 0. You can divide by p minus 2 for p not equal to 2. So I get sine 4x is not equal to, p minus 2 cancels, for p not equal to 2 1s are 2 2s are 1 by 2 into p minus 4 I'm getting. Sine 4x is not equal to 1 by 2 into p minus 4 for p not equal to 2. For p not equal to 2. Okay, p minus 2 has been cancelled. So sine 4x is not equal to 2 ones are 2 2s are cancelled. 1 by 2 into p minus 4. Sine 4x, we know range of sine function is a closed interval minus 1 to plus 1. Sine of any real number always lies in the interval minus 1 to plus 1. So sine 4x is not equal to 1 by 2 into p minus 4, means base should be the value of 1 by 2 into p minus 4 lies. This value should be either greater than 1 or it can be less than minus 1, because sine function always lies between minus 1 to plus 1, right? Sine function always lies in the interval minus 1 to plus 1, including the endpoints. So, if an sine 4x is not equal to this expression, means where this expression should be, either it is greater than 1, if this expression is greater than 1, or if this expression is less than minus 1, then sine 4x can't be equal to that number, correct? Sine 4x always lies in the interval minus 1 to plus 1. Sine 4x can't be greater than 1. Sine 4x can't be less than minus 1, correct? So this expression should be greater than 1 or it should be less than minus 1. If we solve, we'll get sine 4x not equal to this value. So I'll take, since sine x always lies between minus 1 to plus 1, since sine of 4x or sine of any value always lies in the interval minus 1 to plus 1 for all x belongs to R, correct? Sine 4x is not equal to 1 by 2 into p minus 4, means sine 4x and sine 4x is not greater than 1 and sine 4x is not less than minus 1, correct? Sine 4x is not greater than 1 and otherwise I can write a comma here. Sine 4x is not greater than 1 and also sine 4x is not less than minus 1, correct? Sine 4x can't be greater than 1, sine 4x can't be less than minus 1. So I'll solve this with greater than 1 and less than minus 1. Therefore 1 by 2 into p minus 4 is greater than 1 or 1 by 2 into p minus 4 is less than minus 1. Solve this so that sine 4x can't be equal to that value. So if we solve this, what we get? 1 by 2p minus 8 minus 1 greater than 0, or here 1 by 2p minus 8 plus 1 is less than 0. So from this, if we take common denominator 2p minus 8, what do you get? 1 is 1 by 1, 1 minus of 2p minus 8. 1 minus of 2p minus 8 is greater than 0. Or here 2p minus 8 is common denominator here. 1 plus 2p minus 8. Correct? 1 plus 2p minus 8. Here 1 minus of minus 8. 1 plus 8 becomes 9. 9 minus 2p becomes. So what I am getting here is 9 minus 2p. I'll write here 9 minus 2p by 2p minus 8. 9 minus 2p divided by 2p minus 8 is greater than 0. Or if you divide by minus 2 here, I'm going to get p minus 9 by 2 divided by p minus 4. Okay, I'm dividing by 2 for numerator denominator and I'm changing the sign by multiplying by minus 1. So this will be less than 0 because I multiply by minus 1. So according to this, p should belong to the interval 4 to 9 by 2. Correct? P can belong to the interval 4 to 9 by 2. And from this, what we get? This is 2p minus 7 by 2p minus 8, which is less than 0. We can divide by 2 for numerator denominator. We get p minus 7 by 2 divided by p minus 4 less than 0. From this I get p belongs to interval 7 by 2 to 4 because I'm using this concept. X minus a by x minus b is less than 0. X minus a by x minus b is less than 0 means x belongs to the interval ab. Assume that a is smaller than b here. Whichever is smaller, write first. Smaller number first, larger number afterwards. Don't think that A should be numerator only, B should be denominator only, not like that. Smaller number first, larger number afterwards. Okay, so x minus a by x minus b less than 0 means x should belong to the interval AB. So here p minus 7 by 2 by p minus 4 less than 0 means p should belong to the interval 7 by 2 to 4. So if we combine these two, 1 and 2, if we combine 1 and 2, I can write p should belong to the interval 7 by 2 to 9 by 2. 7 by 2 to 4 and 4 to 9 by 2. 4 if we include, no problem. If we include 4, what happens? Denominator will become 0 here, correct? Denominator becomes 0 means what? Sin 4x not equal to 1 by 0. If we put p equal to 4, 1 by 0 I get. Sin 4x not equal to 1 by 2 into 4 minus 1. 4 minus 4, 0. 1 by 0 not defined. Sin 4x not equal to infinity I can take. It's correct. Sin 4x can never be equal to infinity, correct? So that is also possible. So P4 is included, combining these two. I can write P belongs to the interval 7 by 2 to 9 by 2. 7 by 2 to 4, union 4 to 9 by 2. Combining those two, I can write from 1 and 2, P belongs to the interval from 1 and 2, P belongs to the interval 7 by 2 to 9 by 2, which is the interval AB according to the question. So A is 7 by 2, B is 9 by 2. Want to find 16 AB, correct? 16 into A we got how much? 7 by 2. A is 7 by 2. And B we got 9 by 2. 2 into 2, 4. 4 ones are 4 fours are 4 into 7 into 9 is 63. So we get the answer is 252. So numerical type question asked on 9th of April, second shift, JEE Main 2024. Okay. 2 into 2 is 4. 4 ones are 4 fours are 16. 4 into 7, 28 into 9 is 252 is the answer. So with this, all the 15 questions have been completed. Okay. We had 15 questions altogether. I'll show one by one if you want. Once again, this is the 14th question on point of local minima and satisfying that inequality. We had numerical type question, area of triangle, minimizing using AMG inequality, finding maximum area of a rectangle inscribed in the region bounded by parabola and the line we had. And here the question on finding the point of maxima and minima, number of critical points, various questions. Question number 10 was critical points. Question number 9 on finding the number of points of local maxima. And statement 1, statement 2 on increasing and decreasing function, comparing e power pi and pi power e question, finding the interval where the function is strictly increasing. And this is one beautiful question on application type, geometrical approach we go. And again statement 1, statement 2 on increasing and decreasing function, and area of rectangle, maximum, finding maximum area of rectangle, okay, inscribed in another rectangle. This is on graphical approach, finding the number of zeros of the given expression. And the first question was this, finding the domain and finding the absolute maximum and absolute minimum. So all the 15 questions we have completed of the chapter application of derivatives, okay, of 2024 JEE Main of April shift. Okay, many more videos will be uploaded in the coming days, focusing mainly on JEE Mains as well as KCT for the upcoming exams. Hope you are preparing well for JEE 2026 January shift. Please subscribe to my channel and watch the videos, make the benefit of this. Okay, with this I conclude. Thank you.